If you have used Fetch outside of a pet project, you know that the quality of life isn't the best. If you want to have interceptors, retry policies, multiple clients, you'll have to create your functions that are basically wrappers around Fetch. And that also means that, well, depending on how you design those wrappers, you have killed composability, most likely. So you reach for Axios. Axios has great inbuilt utilities, and it just works. However, let me show you a better alternative to both of them. Now, this is kinda clickbait because what I'm going to show you is actually just a wrapper around Fetch. So for this, I'm using Effect and its whole ecosystem. So I'm using Effect Schema, which is a runtime validator like SOD, and I'm using Effect Platform, which brings the HTTP client that I'm going to show you. Of course, I know what you're thinking, 3 libraries just to replace Axios or Fetch? Well, no. Again, this is a runtime validator, and all projects need a runtime validator. So either way, you're bringing one. So we can omit this as a requirement. Then we have Effect, which is the core of everything, and it has a ton of utilities that I would even go as far as to say that Effect is the missing standard library for TypeScript. So in my opinion, this is a must library for all projects. And then we have Effect Platform, which has a dependency on Effect, and this one brings the HTTP client. So in reality, it's just 2 libraries. But again, Effect is more than just an HTTP client, so make sure to check out my other videos on Effect. So with the HTTP client from Effect Platform, there are some things that you need to understand. The first one is that it leverages composition. So every request that you build will be composed. It's not just an argument that you pass into a function and you call it a day. Why? Because you want to be able to define the different building blocks, and then each consumer can decide what to do. You're not enforcing anything. So that means that it is divided into 3 different parts. You have the HTTP client request, you have the HTTP client response, and then you have the HTTP client itself. So let's start with the first one, the request. If you want to make a request, what is the first thing that you do? Well, you define the parameters that you're going to send to an API. So that is the request. You need to construct the request. So for that, you can say HTTP client request, and then here you can say get, you can say put, you can say post, etc. So let's start with a basic one. Let's just say get, then you pass in the URL, and then you can pipe this through. So again, everything is composable. So now here you can say HTTP client and then request, and then you can start defining your building blocks. So for example, if you want to set headers, one way to do that is to say set header if you want only one header, or you can say set headers, and this is going to take in an object. So here you can say content type application JSON. Then you can say request dot, and then let's say you want to send an authorization header. So for that, you can say set header and then authorization, and then you can say bearer, etc. But it has a utility function for that, which is HTTP client request dot bearer token, and you can pass in the token. Now, if you come here to the definition of bearer token, as you can see, it has 2 overloads. The first one takes in the token and returns a function that takes in self. So the HTTP client request that you're going to be composing. And the second overload takes in self first and then the token. So since we're using this in a pipe, everything is implicitly being passed over by each function of the pipe. So that's why we can just use this first overload. Now, how does this work internally? Well, let's take a look. Simply calls set header, which we just used, takes in self, so it doesn't use the other overload, and then takes in the key, authorization, and then the value is bearer, and then the token. As you can see, it's just a wrapper around said header. Now, how can you perform the actual request? Well, for that, you need to use the client. So the client is basically the bridge between what you define as the request and what you can then do with the response. So here you can say HTTP client, and then you can say fetch, and this is going to do your usual fetch, nothing more. But there's another one, which is fetch OK. So this will automatically, for you, so if I come here to fetch OK, filter the status. It is going to ensure that it is within 200 and 300 not inclusive. As you can see, the filter status OK is simply going to say filter or fail, and then it is going to check greater than or equal to 200, less than to 300, and if this predicate is false, then it is going to fail with this error. So new error.response error. Now that's the great thing about using effect, is that errors are values. So you can pattern match against errors, you can have full type safety, and all consumers know what errors they're going to be dealing with, which is something that you cannot achieve with just fetch or just Axios. Now, since this is the first time that we're dealing with errors, so as you can see at this point, we're defining that something can fail, because none of what we have defined so far can fail. I mean, we're just defining that we want to do a get. This internally is just going to construct that data for you, but it is not doing anything. Same with this set header. I mean, currently we're not setting anything per se. We're composing that it is going to set this header, but until this computation that we defined is executed, well, nothing is going to happen. And same with the bearer token. None of these can fail, but fetch OK can fail. So as I pointed out, it can fail with a response error. So now, how can we consume this? How can we say, hey, we want to expect JSON back, as we do with fetch, where you do the promise chaining, and then you say .json, and you call that, you get back a promise, and if it resolves, you get back unknown as the data, or well, any. Well, for that, you need to use response, because now you're going to define what you're going to do with the response, basically. So here, you can say HttpClientResponse dot, and then you can say JSON. And now, if we take a look at the result, as you can see, it is going to give you back an effect. It is going to succeed with unknown. Why? Because, well, we're expecting to get back JSON, but since we didn't define any schema, it can be unknown. Then we have the HTTP client error for the failure case, and there are no requirements. So no dependency injection for this, basically. So now this is great. This is all typed. You do not get this with Axios or with fetch. But now what if we want to define a schema, because we do not want to get back unknown? Well, for that you can say schema body JSON, and then you just pass in the schema. So here you pass in the fields that you want to validate against. As you can see, this is virtually identical to SOD, to YOP, whatever, just with Pascal case. But we're getting a type error. We're getting this right here, so this function that takes in self, which is an HTTP incoming message and returns an effect, is not assignable to something that is giving us an effect that succeeds with client response and fails with client error. So if you have used effect, you know that you're getting an effect. So you need to flat map the result of this, which is also an effect. You can say dot and then, or flat map, whichever you prefer. And then you just need to wrap this. And now if we take a look at a result, as you can see, it now succeeds with this structure. And what does it fail with? A union of HTTP client error and parse error. As you can see, all errors are represented in this channel, which is great because we can now pattern match against these errors. And then this requires a scope. Now, I won't dive into scopes in this video, but scopes are just a way, in effect, for you to define when to acquire a resource and when to free that resource. So for example, a connection with a database. You want to acquire the connection for the longevity of the function, but once everything is done, you want to close that connection. So that is what scope represents. So you can release resources. Now I'm not entirely sure why this requires a scope. Maybe it needs to free up a resource that it is internally using with fetch. You would have to dive into the source code, but well, you need to satisfy this requirement. So for that, all you need to say is scoped. And this is actually after this parenthesis. And now if we take a look at result, it is never. Now let's say we want to have a retry policy. So if we get back a 503, we want to retry that. But if we get an error decoding the response, so if this fails, then we do not want to retry it, because most likely it is always going to fail. So for that, you can say effect.retry. And then here, you can say the schedule, you can say times, you can say until, and then you can say while. So for example, you want to retry these 2 times while the error is a response error. So as you can see, we have 3 errors here. We have parse error, we have HTTP client error that encompasses request error and response error. Request is when we failed making the actual request. So maybe we do not have an internet connection, so we could never do the actual request. A response error is what we get back from the server. So this is great because we can separate the 2 errors and deal them in separate cases. Most HTTP clients out there combine the 2, so it's hard to know from where the error comes. So here you can say, while the error is a response error, but we need to narrow this down. So we can say, and while the status is different than 503, for example, just to put a random example. But you can schedule this because this is going to retry it right away. So here you can say schedule, and then you can import a schedule from effect, and then you can say spaced. You can say duration, you import that from effect, and then you can say every 10 seconds, for example. But the great thing about this schedule is you can say exponential. So now you can pass in the base, as you can see it takes in the base, which is a duration, and then the factor. So I suppose the factor by default is 2. You can say 10 seconds and then 2. So now by a factor of 2 for 10 seconds. So that's absolutely great, and this is not easy to achieve with other HTTP clients. You'd have to create your own adapters. Now what about timeouts? We want to retry on a 503, but maybe our lambdas take quite a long time to wake up. They have terrible cold starts, and we know that it is going to inevitably fail if we hit a cold start. So we need to discard that request and retry again. So for that, you can say effect.timeout. And then here you can say how long. So you can say, okay, we know that our lambdas can take 30 seconds or 20 seconds. Let's just fail at 20 seconds and retry. So then you can say effect.retry, and then you can say times just 1. And then we can say while the tag is a timeout exception. So as you can see, all of the errors are being built up here so we can match against them. And then we can define a schedule. So maybe after 10 seconds, just to make sure that they have really woken up. And that's it. Now if we take a look at a result, as you can see, we get back the data, we get back an HTTP client error, which encompasses a request and response error, we get back a timeout exception, and finally the parse error. Now how do you actually run this? Well, for that you can say effect.runPromise. And then if you take a look at result, it is just your usual promise. Of course, this kinda defeats the purpose of using effect if you're going to just do a run promise and not handle the errors outside from that. But if you're using effect, you'll see that pretty much everything that you write will be in effect. So you would use run promise only on the boundaries of your system, which you would have error handling for those boundaries. Now, what about a post request? Well, let's try that. Let's come here, HttpClientRequest.post, and then here you define the body as a building block. So ClientRequest.jsonBody, and then you can pass in the body, such as this one, and this internally will actually set the header for you. so this is redundant. But now you're going to get a type error. Why? Well, let's take a look at the type definition of jsonBody. So as you can see, to overloads, you will see this dual API everywhere in effect. Takes in the body, takes in HttpClientRequest, which is self, so you can compose it. But notice that it returns, instead of just HttpClientRequest, an effect that succeeds with HttpClientRequest and fails with HttpBody error. That means that whatever you build after that will be effectful. So this fetch OK is actually expecting just the HTTP with response. So what do you need to do here? Well, you need to say effect.flatMap, and then you can say fetch OK. Now, why is this returning an effect? Why can it fail with this? Well, let's take a look. jsonBody does a map, calls JSON, passes in the body, and then sets the body to the request. But if we take a look at this method, as you can see, it is a try. So try unsafe JSON passes in the body, and it catches the error and transforms it into an HTTP body error, which is a tagged error, so you can pattern match against it. Now, why can it fail? Well, unsafe JSON is a JSON.stringify, and JSON.stringify can throw errors if it cannot be serialized into JSON. So that's why this is represented as an effect. Now, there are some cases where this makes sense. Maybe the input is completely dynamic. You cannot really completely ensure that you're passing in valid JSON, or at least data that can be serialized into JSON. But in most cases, this is not necessary. And if this fails, you want to represent that as a defect, because if you're catching the error, that means that the consumer can pattern match against this error. But most of the times, what are you going to do if you get this error? Well, you're just going to log that and terminate the program, right? Or, well, the function that is calling this. Well, unsafe JSON will do that. It is going to transform this error into a defect, and you will never see this error anywhere. So this depends entirely on your use case. If you need to handle this error because it is completely dynamic, you need that for reporting, you need that for whatever, then use this one. But most of the times, I'll stick with unsafe jsonBody, which is not an effect. Now, how do you create a reusable client? Maybe prepending URL and other information. Well, for that, you need to create a layer, because ultimately your client will be a dependency for your effects. Well, for that, let's start with making the client. So make client is equal to effect, and then you can create a generator function, and then here you can create a client. So all you need to do is say HttpClient.HttpClient, and if you yield this, you get back an HTTP client that is the default one. So with this, you have the default client. So let's call this default client. And then you can say client is equal to default client dot pipe. And then here you can start composing your client. So here you can say HTTP client dot, and then you can say map. And then you can say map input request or map request, or map input request effect if you need to do some asynchronous stuff. Same for map request effect. But for now, let's stick with just map request. Now, if you do this, and if you take a look at the type of request, as you can see, HTTP client request, which is the same that we're dealing with here. So now you can pipe this through. So you can say pipe the request, and then you can say request.prepend URL. And now all requests that you make with this client will have this URL prepended. But you can also add a bearer token. So here you can read from local storage, from your state, or even make a request to your database, to your Redis cache, whatever. So in this case, we can just hard code it for the time being. And now you can return the client. Now, before diving into the layer stuff, how do you consume the client? Well, for that, all you need to do is invoke it, and you pass in the request. So remember, everything is composable. So even though you only see one argument as the request, all you need to do is compose your request, pipe through the get, pipe through whatever you want. So for that, you can say request.get, and then to-dos, and then you can pipe this. You can say set header, and then you can do whatever else you want. Maybe define accept JSON or append URL param, or even override the bearer token, whatever you want, that's up to you. And then what you get back is an effect that succeeds with a client response, fails with a client error, and requires a scope. So now, since we know that in the success channel we have client response, we can actually pipe this client. So we can say HttpClientResponse.json. And then if we take a look at this, we get back unknown. But we can change this to be schema.json, schema.body.json. But well, since you're getting back an effect, remember that for the success channel, you need to say flat map. And then you can do an effect that retry a catch tag. So catch tag, as you can see, we get parse error, request error, response error, and all of these would be propagated here. So what if we were to say httpClient.mapRequest and effect? And then here you get the request, and then you say effect.gen, and then if math.random, then you return effect.fail with a new error, and you yield this. And if not, you return the request, and then you come here and take a look at catch tag, or not catch tag, but rather catch all, and then you get the error here. As you can see, you get back the error. So all errors that can occur here in the definition of the client will ultimately be exposed to the consumer, which makes sense. Now, since this is just composing defaults for all of your consumers, that means that you can also filter here. So you can come here and say HttpClient.filter status OK. And now automatically all requests that you make via this client will automatically filter for status OK. And then, well, you can pipe this through again within here, so you can get the bearer token here if it's an asynchronous operation, and that's it. Now, how do you consume this as an actual dependency though? Because, well, for this you can just yield make client and you're good to go, but I would recommend making this a layer, a service that your effects will consume and require, because depending on your effect, you could have multiple HTTP clients. So you need to inject different clients depending on the consumers. So for that, you can create a class. So my HTTP client extends context and then .tag, and then you say my HTTP client. So this is the key. Make sure that it is unique. It will be saved in a hash map if I'm not wrong. And then here you pass in my HTTP client. So you reference the class itself as the first generic. And then you can say effect.effect.success type of make HTTP client. And this is actually just make client. So let's rename this. And then here you can say public static read only. And then live is equal to a layer. You import that from effect. You say this will be an effect. Why? Because this maker is an effect. So you need to use effect. And then my HTTP client, or you can target this. So it gets the tag, which is this one. And then you can say make HTTP client. And you actually need to invoke this because it returns another function. And that's it. But this is actually depending on the default client. So we need to also provide the default client here. So we can pipe this through, say layer.provide, and then HTTP client.layer. And not here, my bad. This is actually for live. So after the effect, of course. And now you can consume it. So you can say const make some request is equal to effect.generator. And then here you can get the client yield and then my HTTP client. So it will now be a requirement, as you can see here. And then you can return client, get, and then you pipe this through. You do whatever. You do not run this. And then you can say schema body JSON. And that's it. You get back an effect that succeeds with another effect. So we need to yield this. An effect with the body, the errors, requires a scope, and my HTTP client. And now to run this, all you need to do is say effect.provide. you pass in the layer. Then you also need to pass in the scope. So you want to scope the resources for this computation and then run promise and you're good to go. Now, let's say you want some interceptors, you want to have a refresh logic mechanism. How can you achieve this? Well, for this, it is a little bit nuanced, but I would do something along these lines. So I would create a force retry error, which simply extends data.tagged error so that we can have the underscore tag so that we can pattern match against the errors, convention by effect. Then we have the make, and here we have a semaphore. So we make a semaphore that allows only one permit. And the semaphore with one permit, as you know, is just a mutex. That way, we block concurrent requests to the refresh token function. So we prevent having multiple consumers trying to refresh the token at once. So with a semaphore with one permit, they will all wait. Then we have a last refreshed reference, which is just a ref that we make with duration. Now duration is great in effect because it lets you compare seconds with milliseconds with minutes without worrying about conversion. So it does everything for you behind the scenes. So we initialize this with 0 seconds. Then we have the refresh token function. And then here, this is actually not required. So this is not a function. This is just an effect where we get the last refresh duration. Then we get now, which is just duration.millis and then date.now because this returns the milliseconds. Then time since last refresh, we subtract now with last refreshed. Then we check was this last refreshed in the past 5 minutes. Then we compare the dates. If so, well, we know that one of them already refreshed the token for us. That means that this will only be executed for the queued consumers. Now, why do we need to check this? Well, that's because the first one that gets hold of the permit will be the one that actually does the refresh logic, but all the other ones will be queued by this mutex. So once this is finished and the first one that got hold of the permit refreshes the token, then the semaphore will be released and one by one they will check against this logic to prevent refreshing an already refreshed token. Now here you would get the refresh token, you would do the request, get the new tokens, and then after that, you update the last refreshed reference. And then you fail with a new force retry error. And all of these will acquire one permit, so with permits 1. Now here you would also need to handle the errors within the refresh request. What if the user is definitely not authenticated? Maybe the refresh token is invalid. Well, you need to have a way to either terminate your whole program so that all other requests that are pending are discarded, or you need to have a way so that instead of having to check this and then throwing an error, you could have another reference to a flag that indicates if ultimately the refresh was successful or not, so that they never retry the request. Because, well, if the user is definitely not authenticated, you know that you should terminate, bail out of all of the ongoing requests. Then we just wrap this with one permit. So with permits, we acquire this. So as you can see, run the effect and release the permits when finished. If there are no permits available, then they are going to be in standby. And then we create the client. So we say default client, map request, we get the access token from who knows where. And then you prepend the URL, you add the bearer token, you add other parameters, and then you say filter or else. And then you say if it's a for one, then we want to refresh the token. And this is actually different than from for one. I want to get only the requests where the status is different than for one. If this fails, we got a for one, so refresh the token. And then we can also say filter status okay. So even though we know that if we get a for one, this will never be executed, but if we get a 404, a 400, a 500, this will be dealt here. And finally, for the client itself, we return a function that takes in the request. We invoke client with the request, and then we pipe the client, and then we do a retry just one time if it's a force retry error. Now if we retried and for for some reason we get another force retry, well, we catch it here and then we die, so we terminate the whole program saying already retried once, twice means you're not authenticated. And that's it. And to consume it, again, all you need to do is invoke client, you compose the request, and then you do whatever you want. And that's it. You have your beautiful interceptor. Now here I would use flow, which is like a pipe, but the input is the function it returns, just to make it a little bit more concise. But to make it explicit, I went for this. And that's it. I hope you learned a lot. If you want to see more content like this, make sure to subscribe. I'll see you in the next one. See ya.